Hey Jack, sorry it's so late getting back to you, but I wanted to go over those questions that you texted me. The first one you sent me was this quadratic equation, and it wanted to know what the factors were, and I put all of the options that are here. You have two choices here. We can play algebra, and we can actually factor this. We can say, okay, well, this quadratic factors into two binomials, and we ask ourselves, what can I multiply together to get x squared? And the only option is x times x. And then you ask yourself, what can you multiply together to get 18, but has a sum or a difference of 3? So I know that 6 times 3 is 18, and I also know that 6 minus 3 is 3. So I'm looking at 6 and 3. I need a negative 18 and a negative 3x. So usually this sign right here will tell you that the signs are different if it's a negative. If it's plus, it means the signs are the same. But what I really just do is I know, okay, well, I know that a negative 6 plus 3 is negative 3. And that's the negative 3 I need. So your answer here is A. That's the factoring way. If you don't want to do the factoring way, then you can use these answer choices and you can use the FOIL method. Remember, we multiply our binomials, we multiply the first term, the outside term, the inside term, and the last term. So you can just kind of guess and check, right? Pick one, check it. If it's not correct, move on to the next one. So if we started that process here, we would say, okay, well, x minus 6 times x plus 3. Multiply the first terms together. X times x is x squared. Multiply the outside terms together. So x times 3 is 3x. Multiply the inside terms together. Negative 6 times x is negative 6x. And then multiply the last terms together. Negative 6 times a positive 3 is a negative 18. When you combine your like terms here, you get that x squared. 3x minus 6x is negative 3x, and then minus 18. Notice that is the quadratic we started with, so that means these have to be the factors of that quadratic. If you got something different, then you would say, oh, the answer is not A, and you'd move on and you would multiply those binomials out also. That's up to you, whichever way you want to do it. Do you want to factor it, or do you just want to multiply them out and see which two give you the quadratic? Okay, let's look at the second one you sent me. So for this one, it asks you to simplify this expression, and it gave you, multiple choice. I first recognized that 3 is a factor of both terms, so I can pull out the 3 or factor out the 3. So I can say, okay, I'm going to factor out a 3. What can I multiply 3 by to get 3x squared? X squared. What can I multiply 3 by to get 27? Or negative 27, really. Negative 9. So if I were to go back through and distribute this 3, I would get 3x squared minus 27. So now we have this 3 times x squared minus 9. There's this rule. It's called the difference of squares. It says if you have two squares and you're subtracting them, that they factor into this binomial where you have a plus b and a minus b, where a is the square root of a squared and b is the square root of b squared. So over here, we have the 3 out front, and x squared, that's a square, and 9 is also a square, and they're subtracting, so we're looking at the difference of squares here. The square root of x squared is x, so I can put an x here. The square root of 9 is 3. 1 is a plus and 1 is a minus. So on your multiple choice there, you would have picked, it looks like B. B was the answer choice that had 3 times x plus 3, x minus 3. Again, if you didn't remember this rule for the difference of squares, you could just go through and multiply out each of your options to see which one gives you this 3x squared minus 27. Let's see, you sent me one more. The last one you sent me isn't so much algebra, but more of a logic, kind of geometry. It says that a board is 120 inches long. So we have a board, it's 120 inches long. Wow, okay. It is divided into 2 sections. The ratio of the 2 sections is 3 to 5. What are the lengths of the sections? So what that means is for every 3 inches in the first section, there's 5 inches in the second section. You can write a ratio as a fraction, 3 over 5. So that means that every 3 inches from one section, there are 5 inches in the second section. Let's see, personally, I would say, okay, I need to multiply this numerator and this denominator by the same number. I don't want to change the value of this. Remember, when you multiply anything by 1, you're not changing its value. 10 times 1 is 10. 20 times 1 is 20, and so forth. So multiplying 3/5 by 1 isn't going to change its value. I'm going to multiply it by this very tricky one, this x over x. Also remember that anything divided by itself is 1. So what this now says is I've got 3x over 5x. Or I want to multiply each piece by this number. We don't know what it is. It's called x. So when I add these together, this 3x and this 5x, they have to add up to 120. Combine my like terms here, and then divide by 8. So we'll divide by 8. 40, 15, there we go. So that means I'm going to multiply this first term by 15. So 3 times 15 and 5 times 15. I don't remember that one off the top of my head. So the lengths of your 2 sections are 45 and 75 inches. So your answer there was D. There's a long way to do this. You could say, okay, 3 inches here, 5 inches here. That's a total of 8 inches. We need to get to 120. So I could say, okay, add 3, add 5. So now I've got 6 and 10. So now I've got 16, right? And you could keep going until you got to 45, 45, and 75. So you would have had to go like 15 times before you got there. Definitely would take longer. I like this way better, where you know the ratio. So you can say multiply each part of that ratio by the same number. You don't know what it is. And then add those two together to get the total that you needed. Solve for x, and that'll tell you what you need to multiply each part of that ratio by to get the separate parts. Since this was multiple choice, you could use that to your advantage. And it had like 15 and 105, right? Let me make this bigger. So if you had 15 and 105 as your answer choices, you could make that a fraction and you could simplify that. Let's see, 15. 5 goes into 15 3 times. 5 goes into 105 21 times. So that reduces the ratio 3 to 21. That was not what we wanted, so that couldn't be your answer. So, and they would also have to add up to 120. 15 and 105 did equal 120, but that ratio didn't simplify to 3/5. So then if you look at part B, option B was 24 and 96. 24 to 96. Make sure that they add up to 120. They do. And then see, is that ratio 3 to 5? Well, 24 and 96, let's see. I see they're even, so I'm at least going to say, okay, well, 12, 45, 48, which reduces 2. 12 goes into 12 one time and 48 4 times. That's not 3 to 5. So then option C said 40 to 80. That adds up to 120, but that fraction reduces to 1/2. That wasn't 3/5. So then you can check 45 to 75. I wrote it as a fraction, but 45 to 75. They add up to 120. 5 goes into 45. 5 5 goes into 45 9 times. And 5 goes into 75 15 times, so we have to reduce that one more time. 3 goes into 9 3 times, 3 goes into 15 5 times, ding, 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 there's that 3/5. So if you didn't want to go through this whole process, or if you didn't remember this whole process, you can guess and check the answers. You can see, do those answers actually give you the ratio 3 to 5? If they don't, then they can't possibly be the answer. So there's a little roundabout way to do it too. I hope that helped. Good luck on your test. I'm rooting for you. You're going to do great.